Jai Hind everyone. I, Dr. Prashant Tripathi, going to present a lecture on the topic Vocoders. This topic belongs to a subject wireless and mobile communication, and the code for this subject is BEC071. This course is basically belongs to BTech final year student of Electronics and Communication Engineering branch. This topic basically consists of voice coder and type of vocoders. When we talk about vocoder, vocoder basically stands for voice coding. Before the vocoders, there is always a problem of how to analyze and synthesize the human speech. To solve this problem, vocoders are proposed. In vocoders, we analyze as well as synthesize the human speech to artificially create the human speech. As we can see that a vocoder is an audio processor that is used to transmit speech or a voice signal in the form of digital data. This is shown in this figure, in which a human voice is translated into a sequence of binary digits. The vocoder is used as a short form of voice coder. As I told that this vocoder is a combination of voice and coder. So basically vocoders are used for digital coding of speech signal as well as it is used for voice simulations. The bit rate for available narrowband vocoders ranges from 1.2 to 64 kbps. Basically, vocoders operate on the principle of formants. Formants are basically meaningful component of a speech that is generated due to human voice. Actually, in human voice, there are various components which may be discarded during the transmission, and when we discard these components, at the receiver side, these components does not contribute any significant information in reconstruction of a speech signal. That's why we know we need only important components for the transmission of voice so that we can easily fabricate the original voice signal at the receiver side. These meaningful components are known as formant. Whenever a speech signal is transmitted, it is not needed to transmit the precise waveform. We can simply transmit the information by which one can reconstruct that particular waveform. This reconstructed waveform at the receiver must be similar and not identical to the waveform actually transmitted. So, the vocoder is used for this purpose also. Vocoder basically work in such a manner that it first captures the characteristic element of the signal. Then other audio signals are affected by the use of that characteristic signals. These vocoders are basically used for voice synthesis. The vocoders take two signals and create a third signal using the spectral information of the two input signals. It aims to emblem the amplitude and frequency characteristics of the speech signal onto the synthesis signal while maintaining pitch of the speech signal. In this diagram, we have drawn a model of vocoders. When we talk about human speech signal, the speech signal consists of two kinds of voice. One is known as voiced signal, voiced sound, and another is known as unvoiced sound. Basically, voiced sound corresponds to letter when we talk about like A, B. These pronunciations are come under the category of voiced sound, but when we spell some letters like F, the air which passes through our lips produces an unwanted sound which is known as unvoiced sound. So, when we model the vocoder, we take two kind of sources. One source correspond to voiced sound, which is synthesized by a impulse generator, and this impulse generator frequency correspond to frequency of our vocal cords, and the signal which is generated by this impulse generator corresponds to voiced signal, whereas the unwanted sound which generates when we pronounce some letters like F, P. So, in this case, these unwanted sounds are generated or synthesized by a noise generator. The switch decides that at which source we are getting the sound. When we need to generate voiced sound, this switch corresponds to impulse generator, but when we need unvoiced sound, the switch changes its position and comes under the noise generator. The filter represents the effect of nasal and vocal cavity. So, this filter shapes the sound which passes through this filter, and at the receiver end we have synthesized speech signal. We know that the adult male voice has a frequency of 85 to 180 Hz, and adult female voice corresponds to a frequency of 165 to 255 Hz, whereas the children's voice frequency range are 250 to 400 Hz, and it can be higher also. This is the block diagram of generation of human speech signal. As I told that the air which passes from these lungs go through these vocal cords, where the vocal cords vibrate from the air which passes through this passage, and with the vibration of these vocal cords, the vibration flow towards nasal cavity and oral cavity, and with the oral cavity and nasal cavity we generate the human speech signal. As we can see that the speech is produced from a filtering operation which performed by the larynx, pharynx, oral cavity and nasal cavity. The sound channel is a physiological filter that shapes the stimulus from the lungs. Different sounds are formed by changing the filtering characteristics. The characteristics of filter changes depending on the position of tongues and leaves. The voiced sound formation starts from the lungs. The midriff muscles press the lungs and causes overpressure to the trachea. The vocal cords start to vibrate at frequency called the fundamental frequency. The frequency of voice vibration is about 100 to 110 Hz for male and 200 Hz for female. The main difference between the voiced and unvoiced sound is that voiced sounds have greater amplitude, whereas the unvoiced sound have a smaller amplitude. Unvoiced sounds are similar to random noise. We have drawn a human speech production model in which the voiced excitation, as I have told earlier, which we have generated from the impulse generator, and unvoiced excitation is taken from the noise generator, and to generate the effect of nasal and oral cavity, we have placed a filter which reshape the stimulus, and at the end we get the speech signal. The vocoder basically processes only the parameters of the vocal model over the communication link instead of a point-by-point recreation of the waveform. Since the parameter changes slowly as compared to the original speech waveform, the bandwidth required to transmit speech can be reduced. This allows more speech channels to utilize a given communication channel. This thing we have already discussed. Now, this is the basic block diagram of vocoder, in which the entire human speech, which ranges from 200 Hz to 3200 Hz, is divided into 15 frequencies band, and each frequency band has a bandwidth of 200 Hz, as we have demonstrated here also, that in first channel the frequency range is 200 to 400 Hz, second channel 400 to 600 Hz, and 15th channel 32 to 3000 to 3200 Hz. So the entire speech is divided into 15 narrowband signals, and these narrowband signals are passes with the rectifier and low pass filter. The combination of rectifier and low pass filter produces a DC voltage. At the last, these DC voltages are combined, multiplexed, and analog to digitally converted for the transmission. In 16th channel, the entire speech signal is applied to the frequency discriminator, and this frequency discriminator generates a voltage corresponding to the input speech frequency. When the speech is voiced sound, the voltage corresponding to this signal is greater, and when the speech is unvoiced sound, the voltage is low as compared to earlier one. The output of this low pass filter generates a DC voltage proportional to voice frequency, which is known as pitch. The entire information is combined and transmitted at the receiver side. At the receiver side, the signal is demultiplexed and converted back into analog form, and at receiver side we have a combination of balance modulator and band pass filter. The range of band pass filter ranges from 200 Hz. Like in first channel we have a band pass filter whose frequency ranges from 200 to 400 Hz. In second channel we have filter with frequency range of 400 to 600 Hz. And in this lower part we have a decoder which detect that the incoming voice signal is voiced or unvoiced sound. When the amplitude of received signal is low, the decoder decides in favor of unvoiced sound, and when the amplitude is higher, then the decoder decides in favor of voiced signal. So at each signal, the balance modulator multiplies the received signal along with the voiced and unvoiced sound, which is determined by the decoder. The output of each band pass filter is balance modulator is fed into band pass filter, which further segregate the desired information, and at the last end this adder combined all the retract information and produces the speech output. So this is the most common voice encoder decoder block diagram which we uses frequently. Now we will discuss about the types of speech coder. So basically, based on the coding techniques, we have four types of vocoders: waveform coders, voice coders, hybrid coders, and analysis by synthesis coders. In waveform coder, the original shape of signal waveform is preserved, and this is better suited for high bit rate coders like pulse code modulation and adaptive delta pulse code modulation. In this waveform coding technique, the original shape of the waveform is preserved. Second is voice coder, which is known as vocoder. So in vocoder, we do not transmit the exact shape of the speech signal. Rather than transmitting exact shape of signal, we transmit the characteristics of the speech signal. By using this method, we can save the bandwidth, and speech signal is generated from a model which is controlled by some parameters, and during encoding, parameters of the model are estimated from the input speech signal. These parameters are transmitted as the encoded bit stream. The quality of decoded speech signal depends on the model, and this model is best suited for low bit rate voice transmission. The example for this vocoder is G.729 vocoders. Next is hybrid coders, and the hybrid coders are a combination of waveform coders and vocoders. In this coders, the additional parameters of the model are optimized such that the decoded speech is as close as possible to original waveform. These coders are best suited for medium bit rate. Next is analysis by synthesis coder. This is the improved form of vocoders. Actually, in this analysis by synthesis coder, the synthesized signals are extracted from the given codebook structure. This model is best perceptual match to the original speech by comparing each synthesized signal to the original one with the minimum error. The parameters representing the based excitation signal and corresponding production filter are then sent over the decoder. Examples of such kind of vocoders are Z.729 ACELP and CSACELP speech coders. Next, the type of vocoders are LPC10, which utilizes the linear predictive coding. Next is excited linear prediction, mixed excitation linear prediction, and adaptive differential pulse code modulation. In this excited linear prediction, main principle is called analysis by synthesis. It means the encoding is performed by perceptually optimizing the decoded signal in a closed loop, and this technique is based on three ideas. The first is it uses a linear prediction model to model the vocal tract. It uses codebook entries at input of the linear predictive model, and third is the search performed in the closed loop in a perceptually weighted domain. In mixed excitation linear prediction filter, it is the improved and modified version of code excited linear predictive coder known as LPC10. Traditionally, pitched excited linear predictive coders are used either a periodic pulse train or white noise as the excitation for an all-pole synthesis filter. These vocoders produces intelligible speech at very low bit rate, but they sometimes sound mechanical or buzzy and are prone to annoying thump and tonal noises. These problems arises from the inability of a simple pulse train to reproduce all kind of voice speech. The mixed excitation linear prediction coder uses a mixed excitation model. that can produce more natural sounding speech because it can represent a richer ensemble of possible speech characteristics. MELP encoding is robust in difficult acoustic environment with significant background noise and reverse re, rever, and these frequently encountered in commercial and military application system. These are the few models which is used in mixed excitation linear prediction coder, like mixed excitation aperiodic pulses, adaptive spectral enhancement, pulse dispersion, Fourier magnitude modeling. When the input speech is voiced, the mixed excitation linear predictive coder can synthesize using either periodic or aperiodic pulses. Aperiodic pulses are used most often during transition regions between voiced and unvoiced segment of the speech signal. This feature enables the decoder to reproduce erratic glottal pulses without introducing tonal sound. The adaptive spectral enhancement filter is based on the poles of the linear prediction synthesis filter. It enhances the formant structure of the synthetic speech and improves the match between the synthetic and natural bandpass waveform. It also gives the synthetic speech a more natural quality. This is the block diagram of mixed excitation linear predictive coder, which contains pitch and aperiodic flags, which passes through inverse discrete Fourier transform. This is the shaping filter, and this output of shaping filter are combined depending upon the whether it is the voiced sound or unvoiced sound, and the speech is generated here. Next is adaptive differential pulse code modulation. This is also a very efficient digital coding of waveform. In this adaptive delta pulse code modulation, we utilizes the knowledge of the signal in past time to predict it in the future, the resulting signal being the error of this prediction. Pulse code modulation, basically in adaptive delta pulse code modulation, the pulse code modulation is performed before this to decrease the number of bits for coding by passing through a PCM process before transforming to an adaptive delta pulse code modulation sample. According to G.726 recommendation, which currently includes G.721 and G.723 recommendation of the International Telegraph and Telephone Consultative Committee, it is specified that an 8-bit PCM word should be reduced to a 4-bit adaptive delta pulse code modulation word, correspondingly reducing the bit flow by a factor of 2. So, in this adaptive differential pulse code modulation coder, we can further reduce our bit rate. So, this is all about vocoders. While preparing this material, I have used two books. One is from Rappaport and another is Upen Dalal. Thank you. Jai Hind.